Okay, welcome back to part 2 of the video. In part 2, we're going to just keep practicing our scatter plots, our trend lines, line of best fit in the calculator, and the correlation coefficient in the calculator. So on number 2, they didn't give you a table. This time they gave you a graph with all the points already plotted. So in this situation, it's easy to see the trend of it, but in order to calculate the line of best fit, you're going to actually have to draw a table and write out all of the data points in your table. So go ahead and do that first before you do everything else. And then I want you to answer all of these questions to the very best of your ability. You'll probably have to check back on your notes from part 1 to do the line of best fit in the calculator and to turn on your diagnostics with the correlation coefficient. If you haven't reset your calculator, then the diagnostics are still on from when we turned them on in part 1. And then you're going to use your line of best fit for part F, and you're going to plug into your new equation for 10 days. So days are our x values. So for your x value, you're going to substitute in a 10 and solve it for y to find out the number of free throws. So go ahead and do the work. Pause your video while you do it. When you get it completed to the very best of your ability, start the video back up for the explanation. Okay, the solution to number 2 is actually very straightforward as long as you know how to get the information out of your calculator, and as long as you were able to plug in the number of days of practice into your equation correctly, then you would have gotten approximately 11 to 12 free throws. Okay, let's turn the page. Okay, on number 3, this time they're back to giving you a table. The thing they've added on number 3 is parts E and F. In part E, they've given you a time of 77 minutes. So our time is our y value. So they've said y is 77. So you're going to plug in 77 for y, and you're going to solve your line of best fit equation for x. And then for part F, they've given you the duration of 5 minutes. So they've given you an x value of 5. So again, you're going to use your line of best fit, and you're going to plug in 5 for x and solve for y. So go ahead and do this to the very best of your ability. Get it as completely answered as you can, and then check back for the explanation. Okay, welcome back. So on this one, when I was looking at the table of data, it wasn't in any particular order, so I couldn't decide, hey, my x's are going up, my y's are going up, there's a positive correlation. So what I did was a quick and dirty graph of the data, and then it was very easy to see that I had a positive correlation. Other than that, it was just a matter of putting everything correctly into the calculator and getting the information. Okay, so the rest of these, number 4, 5, 6, and 7, are you're going to determine from looking at the situation what the correlation is. If both of the data are going the same direction, increasing together, decreasing together for positive, or if they're going opposite directions for negative, or if there's no relationship at all. But the other thing that you're going to be doing is deciding on causation. So you can hear the word cause in it, like cause and effect. So the question is, does one piece of data cause something to happen to the other piece of data? So that's what causation is. So I want you to pause your video to work through all 4 of these, figuring out what kind of correlation you have, and then does one piece of data cause what's happening to the other piece of data? Give it your very best shot, explain your thinking in your answers, and then check back and see my explanation. Okay, take some time to look over the answers on 4 through 7. There are always arguments with this stuff. You saw where I put there may be a positive correlation. There's possibly causation. We can argue and argue. It's real easy when we get down to, that eating organic food is not going to cause you to have a good score. The data may show some positive correlation. It's hard to say. So it's kind of a soft part of the science, but it gives you some idea of what the words mean and how to start analyzing it.